So this is quite a difficult question where it's asked you to find out all the horizontal tangents to the curve with this equation. So just imagining a normal cubic curve, it's unrelated to this question, but it helps you imagine when a horizontal tangent actually appears. So at stationary points, if we drew a tangent, it'd be a strictly horizontal line. So that tells us that horizontal tangents appear when dy dx equals 0. And on top of that, we know that they're strictly horizontal lines, which means the lines are in the form y equals something. So we need to find all the equations of the line in this format. Like I mentioned here, we first differentiate, find dy dx, and then make it equal to 0. So let's do that to the whole of this equation here. Now, when you differentiate y squared with respect to x, that's implicit differentiation. So you differentiate it as you normally would, but then you have to remember to multiply dy dx onto it. If you haven't done implicit differentiation, just let me know in the comments and I'll make a video about it. Differentiating each of the other terms, x to the power of 4 differentiates to 4x cubed, minus 4x cubed differentiates to minus 12x squared, and 36 differentiates to 0 because it's a constant. Dividing both sides by 2y to get dy dx we get that is equal to all of this. Now, if you remember, I mentioned that dy dx, we have to set that as being equal to 0. Now, when does a fraction equal 0? Well, you can never divide by 0. That's impossible. But when the numerator is 0, 0 divided by anything will always equal 0. So that means that this fraction is equal to 0 strictly when the numerator, 4x cubed minus 12x squared equals 0. So you're probably thinking, okay, but how am I going to get equations of horizontal tangents from there? Well, actually, if you find the x-coordinates at which the horizontal tangents appear, or the x-coordinates of the stationary point, which we're doing by making dy dx equals 0, we can put that into the equation of the curve and find the y-coordinate at that point, and we can say that's the equation of the horizontal tangent. So let's break that down. Start by making this side equals 0, so we can factor out 4 and x squared from both of these terms. To go from 4x squared to 4x cubed, you multiply by x. To go from 4x squared to minus 12x squared, you multiply by minus 3. Make all of that equal to 0. Now, the left-hand side equals 0 either when x itself is equal to 0 or when x minus 3 is equal to 0, in which case x is equal to positive 3. So that tells you that there's two stationary points at 0 and 3. If you put x equals 0 into this equation here, we get y squared is equal to 0 take away 0 plus 36. Now, it's important when you square root both sides that you take both the positive and the negative root. Doing the same for when you put x equals 3 into this equation, we get that, well, when you put x equals 3 into the equation, y squared actually ends up equaling 9, which I just pre-did on my calculator. From there, you can get the values of y by square rooting. Remember to include the positive and negative root. That tells you that the stationary points are 0, minus 6, 0, 6. So let's write these out actually. 0, minus 6, 0, 6, 3, minus 3, and lastly 3, positive 3. If we think about it from here, if these are stationary points, that means that, so let's say this stationary point was minus 1, 2. That means that the equation of the horizontal tangent is y equals 2. So what we can do is we can just take the y-coordinates and say that the horizontal tangents are where y are equal to those individual y-coordinates. So when y equals minus 6, y equals 6, or y equals minus 3, y equals 3, they're all equations of horizontal tangents, according to this theory that we have here. Just to show you another example, if this coordinate was 2 minus 1, then y equals minus 1 is the equation of the horizontal tangent. Quite a unique question, which is why I wanted to go through it, but hopefully it all made sense, and if you have any questions with it, just let me know in the comments. Otherwise, be sure to like the video if it helped and subscribe. I'll post more content like this.